studies relating to the failure and success of various industries in the fashion and textile manufacturing sector. From the earlier chapters, Chaps. Lean manufacturing. Case studies from fashion and textile industries, digital technologies for lean manufacturing. It has been clearly mentioned that the implementation of various lean tools such as Kaizen, Muda, 5S and Kanban can help the traditional industries to improve their productivity and efficiency by reducing waste. This chapter will discuss the implementation of lean manufacturing by some of the fashion and textile industries and its impact on productivity and efficiency. The chapter has been divided into 3 sections for better flow and understanding. The first section will discuss some case studies focusing on the failure of some of the industries from Africa and India due to not implementing of lean manufacturing tools. The second section will focus on the case studies focusing on the success of some of the fashion and textile industries by adopting lean manufacturing tools. Finally, the third and last section will focus on the future directions and conclusions of this chapter. Keywords Case Studies Fashion and Textile Industrial Lean Tools Failure and Success Efficiency.
1. Introduction.
With the constant development of the fashion and textile industry, companies that insist on traditional methods and neglect the application of advantageous tools such as lean manufacturing have to cope with inferior positions in their own growth as well as in the market. In specific, insisting on traditional methods expose them to competitive disadvantages with lower production, lower level of customer satisfaction, an increase in the lead time, and so on. Furthermore, since the fashion and textile industries are running in steep competition and in a sustainable product-driven market, they need to be productive and efficient. Further, the diversity in customers' orders, differences in order size, and design requirements would expose the firms that choose not to adopt lean manufacturing to a more vulnerable spot when they eventually cannot compete in both price and quantity because of their obsolescent and inflexible production tools. Therefore, these firms are unable to serve the customer demand and possibly face business distress. In the light of the challenges in the fashion and textile industry, lean manufacturing and its tools can assist individual companies and the whole industry to overcome the aforementioned obstacles. In detail, lean practice, which includes tools such as Kanban, Kaizen, 5S system, and just-in-time JIT, is capable of detecting non-value-added operations in the manufacturing process, which can be eliminated to improve the productivity and efficiency. The lean implementation can lead to a better production flow with value stream management, lower production lead time, better quality products and better inventory management. Hence, fashion and textile industries can achieve higher production and customer satisfaction, lower production costs, eliminate waste and unnecessary operation, thus resulting in higher profitability. The fundamental principles and concepts of lean manufacturing have been discussed in earlier chapters. This chapter will focus on various case studies from fashion and textile industries around the globe that are implementing the lean manufacturing concepts. This chapter is designed to understand the practical aspects of lean manufacturing and how to be successful in the implementation of lean manufacturing.
2 Case Study 2.1 Case Study 1 The Adinkra Textile Subsector in Ghana. Textile Industry.
Since the 1980s, when trade liberalization happened, the traditional fashion and textile manufacturing sector in many countries has been confronted with several challenges, Aboyuwa Entiri and Minta.
2016.
Especially, the conventional sub-sectors in the textile industry are recognized as the most vulnerable to those challenges, which have the highlight being the onslaught of the rising digital age.
Hence,
changing the way textile production processes. The case study on the withering of Adinkra, a small-scaled textiles cloth printing sub-sector, could be examined to demonstrate the bigger picture where there are knotty problems that the traditional ion and textile supply chain is facing. Cordy and Abor 2011 discovered in their research that there has been a consistent, continuing decline in the number of both large and small-medium textile and garment manufacturing companies in Ghana.
Since the mid-1970s,
this decline is seen as a result of both unfavorable government policies and changes in the market forces. From a wider point of view, by 2005, there were only 4 major companies working in the textile field.
They include Ghana Textile Manufacturing Company, Agosombo Textile Limited, Ghana Textile Product, and Printech Quality and Aber 2011.
This also dragged a severe downslide in the number of employees, roughly 8.4 times decreasing in less than 3 decades, as well as yards of fabric produced. Yet, with the purpose to concentrate on the traditional textile industry, the case study chooses to center on the Adinkra hand-printing textile cloth subsector that belongs to the larger textile industry.
Indeed, Adinkra has long attached itself to Ghanaian history and culture, and Adinkra's symbol are immersed to visualize Ghana's
aspects of aesthetics, history, identity, and daily life of the Ghanaian people. Kwarku 1972. It led to the advent of the Adinkra textile cloth production subsector, where Adinkra symbols are imprinted on fabric, producing symbolic textile cloth. With its deep meaning and cultural illustration, Adinkra textile cloth is considered a valuable and prestigious royal craft. Kuwarnu Adjadar et al.
2016.
A field study conducted by Aboyuwa Entiri and Minta 2016 showed a comprehensive investigation of the reasons behind the drastic downward trend in the Adinkra cloth printing and producing subsect. According to their findings, there are 4 main reasons contributing to the gloomy performance of the sector, which include 1. Non-competitive quality of the Adinkra dye, color, and cloth. 2. Lack of financial support for Adinkra SMEs, small and medium-sized enterprises. 3. Challenges on the supply chain. And 4. Outdated production technology. Nevertheless, this case will focus on the third and fourth challenges to be consistent with the topic of the chapter. Firstly, the lack of collaboration between key players in the supply chain of producing Adinkra cloth appears to be the top reason leading to the unproductivity of the products. In reality, the practice to fulfill customer satisfaction in this subsector has failed due to the interrupted joint effort among the stakeholders such as fabric suppliers, dye suppliers, retailers, governmental agencies, and manufacturers. Thus, due to that absence of collaboration, the information flow is disrupted, and the producers of textile cloths only merely based on their assumptions as a result of missing out on customer insight, hence failing to meet the needs of clients. Up to 88.5% of user respondents in Aboyuwa Entiri and Minta's 2016 field study expressed their dissatisfaction with the end products from artisans, and contributing to the downturn of the whole subsector. The inability to capture customers' expectations also led to failure in determining the right price of Adinkra textile cloth, making it too high to attract customers. When compared to other manufactured textile cloths, Adinkra clearly has no competitive advantage. Additionally, the obsolescence of technology and machinery usage is another main reason causing the decline in productivity. Aboyuwa Entiri and Minta 2016 stated in their research that the technology used in producing Adinkra textile cloths was laborious and time-consuming, and that since 1927, the technology had not
been improved.
While the process of finding and disposing of raw materials is of utmost difficulty and sophisticated, no adapted technology was adopted to facilitate the process and the outcome quality. Consequently, artisans have to acquire the dyes from established manufacturing firms, but the dependence upon them also creates certain challenges related to price and quality. Until 2014, vast productions of Adinkra textile were abandoned. Aboyuwa Entiri and Minta 2016, alerting the real state of affairs that Adinkra textile cloth production is on a sharp decline. Thereby, Adinkra is considered as a dying art, both inside and outside of the country. Kofi et al.
2013.
The failure can be attributed to the use of traditional technologies and not being willing to adopt the lean manufacturing concepts in the manufacturing industries.
2.2 Case Study 2. Ethiopian Cotton Spinning Industry.
In the light of the Ethiopian textile industry, it is considered as one of the oldest manufacturing sectors in the country and undoubtedly contributes a great deal to the national economy in regard to both industrial production, employment provision, and profit generation. Shifra 2017. In spite of the Ethiopian government's effort in providing favorable policies for the industry's production and export, the national textile industry also witnessed stagnation. Specifically, according to the Ethiopian Textile Industry Development Institute, the country's textile exports from 2009 to 2016 were falling apart from the plan, only covering around 50–70% of the plan.
Saidazaman et al. 2016.
From a wider point of view, the global competitiveness in this textile industry in general and in the spinning industry, in particular, has arisen as an indispensable factor affecting the performance
of the industry.
The need for textile companies and spinning manufacturers, as asserted by Omd and Ale 2020, is to create higher product quality in addition to improving reputation for reliability,
Manufacturing
capability, cost effectiveness, and timely delivery in response to both local and international competition. Nevertheless, those companies working in the cotton spinning industry in Ethiopia are still facing problems in reaching the optimal point of production capability.
In other words,
Omd and Ale 2020 clearly stated in their research the shortcomings of the traditional total quality management (TQM) methods that have been applied for a long time and certainly are no longer the best approach in such a current time. To be specific, most of the Ethiopian textile industries including cotton spinning are now enduring problems of quality assurance, which is believed to derive from high variations in the production process, the process that is contrary to lean manufacturing. The consequences happen all over the supply chain's different aspects. On the supply side, there are insufficient raw materials. The operation side suffers from the poor performance of product manufacturing, low productivity, and incapability to utilize the production resources. Lastly, on the demand side, customer dissatisfaction is the clearest and most direct evidence showing the lack of an efficient production chain. As a result, more time is needed for the whole production process and more waste is generated during the mentioned process has constrained the industry from developing and gaining a competitive edge, as well as sustainability in the export market as it used to have in the previous time. In the end, these problems led to low-quality products, high cost, and put most of the Ethiopian textile and spinning companies in the situation of being in inferior positions when it comes to competitiveness and profitability. In their research, Omd and Ale 2020 find that spinning manufacturers in Ethiopia only perform using the traditional quality control system. The statement is finalized in light of the lack of new and more efficient quality control systems such as the Six Sigma method or other advanced technology, programs, and tools. Therefore, the authors choose to take those approaches as recommendations for the current Ethiopian spinning and textile industries. If continuing to adopt those traditional quality management systems, it is expected that those systems will no longer be suitable for the emerging challenges of the production detriments and the high cost associated with production waste.
2.3 Case Study 3 Traditional Handloom Sector of Varanasi, Uttar Pradesh in India.
Handloom weaving has always been a crucial, traditional industry of India that not only creates millions of employments for the country but also contributes to the economic as well as cultural aspects of Indian people. Tanushree 2015. Indeed, it is considered to play an essential role in the national economy, being the second largest sector that acquires a huge amount of labor recruitment in comparison to the agriculture industry and accounts for roughly 14% of total cloth produced by the country. Yet, when it comes to the light of industrialization around the world and in the country, the handloom industry has confronted a significant downturn. Tanushree 2015. This sector appears to be a brilliant case study when we take into consideration how much the rise of industrialization can affect such a purely traditional industry of a nation. Before the Industrial Revolution, the handloom appeared to be a strong economic sector with the advantages of having diverse material resources, cheap labor, growing domestic demands,
and relatively simple technology application. Niranyana 2004.
However, since the 19th century, with the powerful penetration of the industrial and technological waves, the sector has been placed in jeopardy and the risk of being suppressed in both domestic and international markets has quickly become visible when the competition started to be extremely intense due to globalization, market liberalization, Ganguly Scrace 2003, and the rise of mechanized manufacturing.
Roy 2002.
Thus, it can be said that the handloom industry, represented by handloom weavers,
emerges as an illustration of the industrialization. Tanushree 2015.
Noticeably, the advent of more and more advanced technology, especially the power loom machine, mostly from foreign manufacturers, that attracted more preference from the customers due to its competitiveness in the price and also consistent quality. Goswami 1990. Consequently, power loom is getting predominant in the market, jumping from 37 to 68% in 1.5 decades 1980-1995, to cover the overall Indian textile products. Mizuno 1996, Srinivasulu 1994. The traditional way of management and resistance to adapt to new changes, as well as new technologies in the current Industry 4.0 era, appears to be the main causes for this decline of the handloom
industry in India. In fact,
keeping the outdated production system with a capitalist management style not only worsens the weaknesses of the industry's nature but also prevents the drivers to gain a better adjustment in the production system. More importantly, this seems to be the root cause of other problems that contribute to the overall disadvantage of the handloom sector, namely labor problems, a detrimental wage system, and a lack of connection in the supply chain. In short, the traditional fashion and textile industry,
e.
the handloom sector, has been confronting numerous challenges when it comes to the fragile competitiveness of the industry as holding. Noticeably, there are two main reasons causing such a downward trend. Firstly, the companies or manufacturers that have long been following the traditional practices of textile production are unable to compete with the rising in both quantity and quality of their rivals. This is due to the waves of industrialization and technological revolution. Thus, when globalization and market liberalization occurred, the traditional manufacturers were quickly put into a disadvantageous position. The second reason derives from the stagnation of the sector in adopting new technologies as well as applying more advanced quality management philosophy and methodology. Their slow response and resistance to the stream of technological development have contributed to the downfall in all aspects of manufacturing. As a result, not only the productivity and quality decline for those companies that pursue the traditional manufacturing process, but they also encounter a huge risk of being eliminated from the market. Due to low customer satisfaction, high cost, and intricate production mechanism. 3. The application of the 5S system. 3.1 Case Study 1. Sample section of the apparel industry in Bangladesh. The sample section plays a crucial role in the efficiency and productivity of every enterprise and factory in the apparel industry of Bangladesh. This section creates impressive communication and maintains a firm relationship with customers by proving quality and quick sample submissions. Khan and Islam 2013. The idea and design of the product are necessary to be displayed with the proper sample, thus avoiding sample rejection, order cancellation, and hesitation in proceeding with future orders for any vendor. The sample section is said to be immensely workload loaded. Limited time and high expectations are given from the customers to dispatch a sample with adequate quality. Therefore, discipline and efficient management are vital. However, there have been many issues occurring within the management of this section. According to Khan and Islam 2013, these problems can derive from insufficient file management, weak inventory management, sanitation standard in the working environment, and incapable workers with
deficient skill and knowledge.
Thus, it can lead to several impacts such as late submission, sample rejection, waste of time, demotivation in the working environment, or quality reduction. As a result, it brings about dissatisfaction from customers, work procrastination, and a higher workload. Accordingly, the 5S methodology has been utilized to improve and optimize the current operation of the sample section in Bangladesh. The current working structure is adjusted with the removal of non-added value items and the restructuring of the working space. In this phase, unskilled workers are pointed out to have better training as well as creating a team with experienced employees. Each team is divided into specific subsection based on their expertise with a sufficient number of workers and distinct inventory storage. Unnecessary machines, materials, and documents are removed and replaced with the current order with proper labels.
Set in order.
In this phase, workers are provided with the systematic arrangement of machinery and items to optimize working time and motions. Wooden or Partex board wall cabinets areas within the department to separate the operation. The lighting system and ventilation are given in suitable partitions. Proper cleaning and arrangement are proceeded after every shift to optimize time management in the long run. The cleaning team is well managed with proper items and separated into specific tasks. In Seiketsu, an efficient workflow is generated. The routine of machinery and utility maintenance and cleaning basis are provided. Each team will have a captain to take charge of storing inventory, sample submission quality, deadline, and delivering instructions to their workers. In the final phase of the 5S philosophy, the proper procedure is established to sustain the habit of the 5S methodology in the first 4 steps. Regular training and practice are processed to enhance workers' skills, motivation, and discipline within the section. Moreover, assessing the implementation in the previous phases can help make appropriate adjustments that suit the current status of the enterprise. After implementing the 5S methodology, sample sections in Bangladesh apparel firms could improve the inventory and file management with a better arrangement of important machinery, material,
and the ailing.
a nation of non-added value items. Besides, sanitation was maintained with a proper cleanliness routine. Moreover, personal skills, knowledge, and discipline were improved with numerous training and practice from the Japanese philosophy. Therefore, production order has been sustainable along with better satisfaction from customers. 3.2 Case Study 2. The improvement of the Italian luxury fashion brand. The name of the company is kept anonymous as Italian Fashion Company (IFC) due to confidentiality. With the primary operation in fur coats production, since the 1950s, IFC has been remarkably growing to become a multinational brand from a quasi-artisan family company, Carmignani and Zamori 2015. Besides its main market in Europe, Eastern countries, Russia and China, North America, and Mexico are contributing a large portion of IFC's total sales volume. The company produces bags, clothing, accessories, and so on, in limited quantities, and all products are made by artisans. The whole operation, including design and production, is processed in Italy with 12 manufacturing factories located near the headquarters. IFC also has a global network of warehouses in Italy, Asia, the USA, and Europe. Nevertheless, its business has been suffering from a downside lately as the contraction in margins, inventory shrinkage, higher transportation costs, and varied market trends. To be more specific, the out-of-date machinery and materials, as well as the increase in unsold products, were the main incidents. Therefore, lean projects have been developed to improve the productivity and efficiency of the business. IFC's objective was to cut its operation cost, inventory levels, lead time and increase flexibility. Therefore, 5S techniques have been used: ASA, visual control, tool to identify wastes in operation and eliminate it to achieve the primary improvement.
Numerous minor problems.
Adequate documentation and consistent procedures have been solved and improved. Accordingly, different sections within the manufacturing facilities are separated with different colored marks to optimize the time and motion of workers. Moreover, the sanitation in the workplace, specifically the equipment, is improved, thus motivating employees with better working conditions. Standard chambers and KLT containers are utilized to separate materials, semi-finished products, final products, and spare parts. Dedicated allocation for each stocking criteria with smart tags can minimize the chance of damage during picking and shipping, as well as optimally identifying stock keeping units, SKUs, and minute AC. Besides, supervised training, workshops, and single-point lessons are provided to optimize the utilization rate of workers since the underskilled workforce is minimized. Thanks to the application of 5S techniques, the efficiency of the manufacturing process has been primarily improved. Therefore, in the combination of other lean methodologies and techniques, IFC can improve its profitability, optimal cost management, and inventory management. Nevertheless, the luxury fashion sector is different from other sectors due to demand seasonality and variability, product customization, and craftsmanship. Therefore, the application of this practice is considered to be rarely possible. For the implementation of value stream mapping. 4.1 Case Study 1. Higher customer satisfaction on achievement in ABC Clothing Limited.
In India.
Hitherto, the textile industry in India has grown significantly with the increasing production volume. According to Kumar and Thavaraj 2015, due to the dissimilar demand, the demanded quantity and design style varies for each customer, thus requiring higher productivity in each firm to serve the demand. Another difficulty that incurs is the high work in process WIP in the conventional batch production. This is the manufacturing inventory that is especially wasteful and should be eliminated to avoid obstructing the production rate. Altogether, these impediments obstruct the company from achieving higher customer satisfaction, hence a potential customer risk that would severely impact the business operation. In the case of an Indian garment manufacturing company, ABC Clothing Limited, with a 100% export-oriented business model, it has to cope with numerous different orders from the UK, USA, and Germany, indicating relevant issues from the industry. With the goal of better productivity, lean manufacturing is a recommended tool that ABC tends to implement in its business. This method aims to detect the major source of operational underperformance and offers proper tools to address mentioned problems. Starting with the Value Stream Mapping (VSM), it can reduce wastes in inventory and defects by visualizing the production process to detect different types of wastes and suggest appropriate methods to
mitigate or eliminate them.
The application of VSM goes through the process of selecting a product lineage and improvement target and the comparison between current and future state maps to manage the implementation process. In this case, the chosen product was men's innerwear with a focus on the sewing sector, Kumar and Thavaraj 2015. From the current VSM, the cycle time is calculated to set the foundation for improvement in the future VSM. Specifically, before each process, specific statistics of the labor force, inventory level, cycle, and change over time are collected under the approach of Rother and Shook 1999 to estimate the cycle time and highlight MUDA process waste in the current operation. As a result, various things are highlighted, such as 1. Large inventories, 2. The difference between the lead time and value-added time of the production process, 3. The on-schedule operating process, and 4. Process ratio at an extremely low level. Accordingly, there are some recommended lean tools that are incorporated while planning for the future VSM, including single-piece flow, Kaizen, and 5S methodology.
To minimize or eliminate stated problem.
The cellular layout is also under recommendation to achieve for the operations the least WIP level, cost efficiency, labor forces skill advancement, and production lead time minimization. Furthermore, after the non-value-added components in the production progress are detected, some of them were extracted from current VSM, while the others were integrated together to lower cycle time and operator association. Eventually, this whole lean implementation yields the achievement of the optimal goal. In detail, the process ratio has increased significantly from the minimization of unnecessary process delay time. Simultaneously, the cycle time, WIP level, and a number of operations have been successfully reduced, which lowers production costs in short-run orders and cuts down operator allocation and space with
in the existing VSM.
Hence, ABC Clothing Limited is capable of being more responsive to customer demand whilst having high-quality manufacturing in the most efficient and economical way with waste reduction or elimination in human resources,
inventory,
time to market, and production space.
5. Application of MUDA, Six Sigma and Statistical Process Control.
5.1 Case Study 1. Applying MUDA concept to natural fiber clothing manufacturing. As more customers go against the cost of waste, businesses are searching for grand tools and techniques for the identification of MUDA in their operations. Rahani and Ashraf 2012. The MUDA refers to the wastes or non-value-added activities that need to be eliminated in the business process for an organization's sustainable growth. The case study of a manufacturing clothing company specialized in natural fiber applying the MUDA concept from the Journal of Textile Institute will be presented in this section.
To identify the MUDA.
A value stream map helping people visualize the whole production process from the method creation stage to the delivery to end consumers stage is constructed. Rother and Shook 1998. The research process is split into two categories. Firstly, the effects of lean manufacturing will be identified, and secondly, a suitable mapping tool's value flow to implement predetermined lean manufacturing will be built to critically find out the MUDAs and in each step with an appropriate solution. Table 1. Specifically, through the company process.
Table 2. 7 MUDAs are correspondingly identified. Table 3.
Table 1 Mapping tools to implement predetermined lean manufacturing to find out the MUDAs in manufacturing.
2. Research state study.
Studying the literature of leaning and the methods of value stream mapping during
observation.
Drawing the value stream map. Interview and consulting with the focus group. Identifying the MUDAs in the value stream map.
ANT technique. Prioritizing the MUDAs. Casual inference.
Presenting general solutions. Table 2 Production process of this company.
State. Activity. Description. 1. Cutting.
Prepare feeding for the sewing stage. Deliver the supplied fabric to the cutting shop. The fabric can be cut in traditional way, hand cutting, or industrial way, utilizing a CNC machine.
2. Sewing
The sewing process takes place at 3 different shops, with ready-to-be-used materials such as wards and knots.
3. Ensing
Clothes are dyed at an enzyme shop and remain in the dyeing pots to achieve the intended colors in a certain period.
4.
Quality control and ironing. The counted returned clothes from the enzyme stage are highly monitored and will be ironed if no enzyme is defected.
5.
Barcoding, folding, and transporting to the storehouse. The finished clothes are barcoded, folded, and transported to the storehouse. Table 3.7 Mudas identified in the production process.
Waiting
The waiting time in the sewing stage, including delivering activities and other processes in the cutting and enzyme stage.
Motion
Improper design of workplaces in each station leading to operators' uneconomic movements and motions.
Defect
Parts of the defected shirts are reprocessed.
Over Processing
Defective products are rechecked. Redo the enzyme process for the returned products.
Overproduction
This muda stem from the malpractice in forecasting, inventories, and final product planning, especially during sale season.
Transportation
The flow of materials and work in process are interrupted due to illogical equipment arrangement. The shop location and route planning is not optimized.
Inventory
The full utilization of push production result in accumulated WIP inventories. A value stream map has been illustrated to identify the mudas in the whole production process. Rother and Shook, 1998. With this done, various wastes hindering the constant operation of production will be minimized. Typegrabber and Debucourt, 2012. Afterwards, an analytical network process ANPI supplied and ranking the mudas respectively based on cost, quality, and delivery via super decision software. Hence, most mudas are found in the sewing process. Specifically, in the overload of transported parcels to each location. With this result, the value stream map is developed to mitigate the waste by increasing transportation frequency and decreasing transported volume, which considerably minimizes the process and waiting time while fulfilling the final expense. 5.2 Case Study 2. Applying Lean Six Sigma to a spinning mill in India. The revolution of quality standard in the textiles and clothing industry has pushed these involving industries to implement modern manufacturing models such as lean tools in their execution. This case study from the Journal of Textile Institute depicts an identical implementation of the Lean Six Sigma and ISO 9001, 2008 standard-based quality management system QMS in a textile mill in India and supports the industry to save up to 2 million Indian rupees annually. As from the name, Lean Six Sigma is the combination of lean manufacturing and Six Sigma. Karthi et al.
2011
The rising concern towards quality, cost, and delivery warrants scientific systems that require the textile industry to apply ISO 9001 for a sustained growth rate. Calisir 2007. From that, the integrated model of Lean Six Sigma and ISO 9001 L6 CUMS 2008 was created with DMAIC methodology, belt-based training infrastructure, and Lean Six Sigma in ISO 9001, 2008 standard-based QMS. Table 4 to mitigate global challenges while boosting the quality degree of the production process. Based on that, 20 hypothetical steps have been built to fully adopt the model in the spinning mill in Andhra Pradesh, India. Table 5. Table 4 The application of Lean Six Sigma QMS to the production process.
1. Scope Lean Six Sigma Project Build Personnel Build Training and Application 2. Normative Reference Devane 2004 Harry and Schroeder 2005 George 2003 George et al. 2005 and Takis Sadegan 2006 3.
Terms and definition. Lean and Six Sigma terms and definitions.
4.
Quality management system.
General Lean Six Sigma Requirement 5.
Management responsibility.
Responsibility of Champion Master Black Belt and Green Belt 6. Resource Management.
Lean Six Sigma belt-based training infrastructure requirements.
7. Product Realization Define Phase Requirement 8.
Measurement, analysis and improvement.
MAIC Process Requirement
Table 5. The implementation of L6 CUMS 2008 model divided in 20 steps.
Step Activity 1. Coordinators Meeting 2. Conduction of Cognizant Programme 3.
Modalities Discussion Meeting.
4.
Head of Departments Meeting.
5. Management Representative Interview 6.
Other Elements Determination.
7.
Meeting with the Technical Manager.
8.
Other Elements Preparation.
9.
Elements Submission to Top Management.
10.
Quality Manual Amendments 11.
Action Planning 12.
Belt-Based Training Infrastructure Enhancement.
13. Instruction Classes Provision 14. L6QMS 2008 Project Begin 15.
L6 CUMS 2008 Project in Execution.
16.
L6 CUMS 2008 Project in Review.
17.
Digital related documents of the project.
18.
Quantitative performance of the project.
19.
Achievements complement to the top management.
20.
Project reviewed by the top management. In the execution, 2 projects aiming to reduce sliver waste generation and ring frame tender training lead time are carried out respectively to confirm the credibility of the model. Particularly, the journey of this case study is illustrated below.
Step 1. Coordinators Meeting.
Structuring the Board of Executives began the journey of all, in which the project coordinator, technical manager, and coordinator were nominated to implement the L6 CUMS 2008. The coordinator will be assisted by the other 2 to be directly in charge of the process.
Step 2. Conduction of Cognizant Programme.
Specific reasons for the integration of Lean Six Sigma and ISO 9001, 2008 is pinpointed in this program. Step 3. Modalities Discussion Meeting. Senior executives will discuss the most optimized strategy for the implementation. After that, a pilot project is decided to be executed before continuing with the whole project. Step 4. Head of Departments Meeting. There will be a meeting between heads of departments to carry out the brainstorming work. This aims to identify the detailed tasks involved in this project to define ways for a profitable execution.
Step 5. Management Representative Interview.
An interview between the coordinator and management representative will be conducted to collect the necessary information for the implementation. Step 6. Other Elements Determination. The comparison of the present ISO 9001, 2008 standard and L6 CUMS 2008 model has been made by the coordinator to determine additional QMS elements to be appended in the existing IMS for L6 CUMS 2008 implementation. Step 7. Meeting with the technical manager. As an outcome of the meeting, new elements of the L6 CUMS 2008 model were appended to the IMS of Unit A. Step 8. Other Elements Preparation. The second-level documentation procedures including other quality and elements to implement the L6 CUMS 2008 model were created. The Vice President of Technical Affairs (VP Tech) was allocated as the champion and the Deputy General Manager (DGM) as the Master Black Belt. Step 9. Elements Submission to Top Management. The L6 CUMS 2008 model's quality manual was submitted to the VP Tech from the Coordinator and Technical Manager. Step 10. Quality Manual Amendments. From the received recommendations by the DGM, the Coordinator revised the Quality Manual. This document was approved by the VP Tech. Step 11. Actions Planning.
As depicted in Fig.
1. The L6QMS 2008 Unit A folder was logically organized with subfolders for instruction classes, standard and manual, procedures and records, project and training. Fig.
1. The L6QMS 2008 Unit A folder.
Step 12. Belt-Based Training Infrastructure Enhancement. Production Manager and HR Manager were assigned as the Black Belts. Production Supervisors and 1 HR Assistant, who took the responsibility of each project respectively, were chosen as the Green Belts. These employers give detailed descriptions of the methods with appropriate tools and techniques after the completion of every phase, with recorded meeting minutes. Step 13. Instruction Classes Provision. For the defined phase, instruction class about project charter, SIPOC diagram, responsibility accountability consult and form RACI chart and cost benefit analysis was conducted.
For the analysis phase, value stream map CTQ3 diagram.
Data collection and analysis plan. Measurement system analysis and gauge repeatability and reproducibility analysis were taught in the measure phase session. To balance between each class, the improve phase and control phase were trained in another session. Both training sessions are carried out by the coordinator.
สเต็ป 14 L6QMS 2008 Project เบกุล
The projects are started by the trainees and supervised by the coordinator and technical manager. Besides, the whole project is monitored by the Master Black Belt and the Mister of Unit every day. Step 15. L6QMS 2008 Project in Execution. The two projects were consecutively denoted as LSS0001 and LS0002, each of which execution steps were highly monitored. For the LSS0001 project, it was aimed to reduce 0.35% of waste from 1.85 to 1.5. For the other, it was aimed to reduce the training lead time by 3 months from 9 to 6 months. Step 16. L6QMS 2008 Project in Review. The coordinator continually scrutinized the projects in terms of their high-level process map, Table 6 Cause and Effect, Fig. 2. Rectification Actions and Results. Table 6 High-level process maps of both projects.
Silver Waste 1
Variables in carding.
2 Variable in SL IL 3
Variables in the comer.
4
Variables in the drawing.
5 Variable in Simplex Training Lead Time 1 Induction Program 2
Disciplinary training.
3 Safety Training 4
Off-the-job training.
5 Teaching Training 6 Gating Training 7 Doffing Training Fix.
2. Cause and effect of both projects. Step 17. Digital-related documents of the project. All documents from the two projects are electronically recorded in the L6RP_Lean Six Sigma record for projects subfolder, which is illustrated in Fig.
3 Fix 3 Denim Washing Process.
Step 18. Quantitative performance of the project. Through applying tools and techniques and organizing training, the implementation of two projects achieved 1 million INR for each project, resulting in a total volume of 2 million INR annually. This proves an outstanding improvement of a textile mill. Step 19. Achievements compliment to the top management. The achievements are proudly presented to the VP, HR, and administration with an impressive reduction in lead time in Unit A. The L6QMS 2008 project is then requested to be implemented in other spinning units. Step 20. The project reviewed by the top management. In appreciation of the coordinator and belt members, the top management meeting was conducted at the central office to review the accomplishment. In conclusion, the L6QMS 2008 project has been successfully completed for a spinning mill in India. The combination of Lean and Six Sigma has never been tried in the textile unit. However, it has then proved to be successful at a full cooperation level without any difficulties. The 20 hypothetical steps have successfully led the employees through an understandable and practicable process to achieve an annual cost reduction of 2 million INR without any significant problems in the given timeframe. This means that no modifications are necessary for the project to be largely launched for the whole business. 5.3 Case Study 3. Applying Statistical Process Control (SPC) to a denim garment in Turkey. This case study pays particular attention to the application of SPC to determine washing defects in the industrial washing processes of the denim garment industry. Denim garments are considered the most important part of the textile industry, since this type of fabric, despite being the oldest one in the world, can always remain popular with a wider range of consumers, thanks to its family wearable characteristic. Throughout the production process, the most important step lies in the washing operation, regarded as the final and a base step to complete any denim product by strengthening a tensile in the fabric and removing hard attitude in the raw fabric. The denim washing technology creates new color tones that suit customer preferences. Specifically, the denim is dyed with indigo dye, which will be discolored after being washed. The SPC method is applied particularly in this process to determine the most common defect and its impact on the overall product quality. The denim washing process will be evaluated in a general framework, utilizing statistical process control methods, namely Pareto analysis, cause and effect diagram, and P-control graphs. As illustrated in Fig. 3, the denim washing process includes 6 stages. The first stage, Desizing refers to using amylase enzymes to break down long molecular, water-insoluble, starch chains into shorter, water-soluble molecules that can be washed away more quickly. After that, the garment is made to become wearable in the rinsing part. At this step, the desized garment will be softened to improve the hand feel of the garment. The washing stage ensures the finished products acquire high color contrast, color pull, and low back staining degree with enzymes. Next, the softening stage, as it is called, provides a soft touch to denim products. Specifically, industrial denim washing includes three types of softeners, namely cationic for all soft products except white-colored ones, non-ionic only for white and light-colored products, and silicones provided softness as well as lubricity. The fifth stage of drying the garment hydro-extract denim garments to remove 80% of water. Since too many garments in the dryer lead to a longer drying time which makes the denim garment back staining, this stage can affect the softening stage result to some extent. After going into details of each step, certain defects have been identified, specifically, the resin spray, permanganate spray, pigment spray, desizing, stone washing, crinkle, enzyme washing,
bleaching,
tint, softening processes in the wet process, alongside the sanding, whisker effect, damage, swift, and laser operations in the dry process has resulted in tons of defects. Fig.
C.
Those lie in every stage of the production and even in the textile sector, which means that the formation of a defect in the denim washing process is also inevitable. Fig.
C. An alternative flowchart for denim washing process.
That given, with the Pareto analysis technique, many defect types have been identified with different levels of importance. Fig. 5 main problems leading to these defects are also clearly defined through the cause and effect chart. Fig.
6. Fig. 5 Pareto chart for denim washing defect. Fig.
6 cause and effect diagram. Eventually, after applying the Pareto analysis and cause and effect diagrams, it is depicted that 80% of the defects stem from the chemical and color-based ground beside other causes. Hence, proper solutions have also been raised to improve the overall process for a more sustainable textile industry.
Table 7.
Table 7 recommended corrective actions for washing defects in process.
No. Defect type. Causes. Corrective action. 1. Chemical defect.
Desizing enzymes. Homogeneity exceeding pH 6 to 7.
Dispersing indigos.
Using cationic or silicone for softening.
2. Ground defect. Insufficient or intensive local permanganate and pigment.
Back staining by ozone.
3. Intensity problem.
After the type of washing, as a result of the narrowing in the width and neck of the fabric and the increase of weft and warp frequencies. Investigations should be made on RINs, enzymes, and stony bleach wash recipes. Time, temperature and stone used in washing recipes, enzyme and bleach, weight, dimensional stability.
4.
Reasons for repairs are wet processes and operational errors due to spray. Faulty products with tone difference or light or dark color on the floor, permanganate at local insufficient or dense.
5. Tinctorial.
Parameters such as temperature, duration and concentration.
Sodium hypochlorite or potassium permanganate bleaching process.
Neutralization and rinsing.
6. Procedural.
Failure to rinse with soft water. The problem is that the rinse water is not cold. Failure to remove peroxide. Hard water causes problems in dyeing due to the high rate of lime it contains. Acetic acid and peroxide killer are added. In addition to these, soft water is added and the temperature is raised to 50 degrees and kept for 15 minutes. If peroxide is 0 and pH equals 7, it means that suitable environment is provided for dyeing. In conclusion, certain defect problems have been addressed to better control the washing processes and take every stage to minimize industry wastes and environmental pollution. The application of SPC is one of the identical examples of a method to achieve the aforementioned objectives.
6. Conclusion.
The traditional textile and fashion industries have been proven to struggle with difficulties by following conventional methods. To be more specific, globalization and market liberalization have induced competitiveness between corporations, thus emphasizing high productivity and effectiveness. Nevertheless, each section of the industry is dealing with distinct barriers around the globe. For instance, the shortcomings of the traditional management system in the apparel industry of Bangladesh or in the cotton spinning industry of Ethiopia have led to declined demand. Moreover, the obsolescence of production technology and techniques in the Adinkra textile subsector in Ghana or the Italian luxury fashion industry has led to the loss of productivity. Additionally, the resistance to the adaptation of new changes in the hand-loom sector of Ind has made this sector sick. Altogether, each sector is facing analogous impediments, which result in underproduction, inefficiency, and low-quality products. To overcome this problem, many industries have adopted different strategies, techniques, and methodologies that are derived from the lean philosophy. The apparel industry of Bangladesh adopted the 5S system to get rid of the insufficient management, low sanitation standard, and incapabilities of workers. Similarly, the Italian giant of the fashion industry utilized the 5S methodology to eliminate non-added value items and waste within its operation. Furthermore, the ABC industry in India applied the value stream mapping and 5S method to improve inventory management and reduce defects within its production system. Besides, the concept of Muda, Six Sigma, and statistical process control (SPC) is implemented respectively in natural fiber clothing manufacturing, Indian spinning mill,
and denim garment manufacturing
in Turkey to improve productivity and efficiency. The improvement of lean philosophy is distinguished between different implementations. Nonetheless, it yields identical results that create advantages for corporations in terms of production and competitiveness. In general, the lean philosophy can help reduce non-added value items, cut production costs, enumerate management systems and customer satisfaction, increase productivity with a lower lead time and
profitability.
As highlighted above, the textile and fashion industries have been attempting to adopt lean philosophy to increase its efficiency and competitiveness. In addition, with the waste reduction, which is the most critical essence of lean, these industries can be able to achieve sustainability due to its major impact on global environmental, social,
and economic problem, preference, abo-argia.
Lean supply chain principles have been well applied to help fashion and textile F&T industry to become more competitive and sustainable. In recent times, the F&T industry has been facing the COVID-19 pandemic with many supply chain disruptions. Lean concepts have changed during the crisis to create a balanced and flexible flow of textile and garment products through lean with agility, supply chain visibility, and green supply chain practices. This chapter discusses the benefits and drawbacks of the lean manufacturing in F&T industries. Further, this chapter also recommends the future development in lean and agility, sourcing flexibility and green supply chain practices that can help the industry to recharge and adjust during such a difficult time. Information technologies such as big data and the Internet of Things play supporting roles in enhancing visibility and integration for a lean and sustainable F&T development, which will be future in the lean manufacturing. Keywords: lean, agility, sourcing flexibility, visibility, supply chain, green practices.
1. Introduction.
The rapid growth in the production of fashion and textile F&T products, associated with rising wealth and fast consumption in developing nations and rich consumers' experience with fast fashion. For decades, it has been defined as a business model based on offering consumers frequent novelty in the form of low-priced, trend-led products. Cleef et al.
2018 Niimaki et al. 2020
The global fast fashion market is expected to grow from $25.09 billion in 2020 to $30.58 billion in 2021 at a compound annual growth rate of 21.9%. Research and Markets 2021. The forecast for the next 10 years, based on this growth, projects that the fast fashion industry will be worth $44 billion by 2028. Teodoro and Rodriguez 2020. Several studies investigated lean and global consumption surges, competitive price, good quality and delivery terms. Lean manufacturing has been cited as a key player in enhancing competitiveness and the growth of the industry. Amaro et al.
2019 Hodge et al. 2011 Purvis et al. 2014
However, the other side of the global consumption, fast fashion trend, sustainable ethics create a big debate in the F&T industry.
เช่น 2014 ในยักษ์ 2020
Literature often questions the balance between lean operations for competitiveness and at the same time sustainable development in F&T supply chains. Angle of 2015. Ardeti and Mutu 2020. Huo et al.
2019 ปากซอย et al. 2019
Since the textile and fashion industry has a long and complex supply chain, Nayak et al. 2019, starting from agriculture and petrochemical production to manufacturing, logistics and retail, Ninimaki et al. 2020, managing the green and social development along with economic aspects become essential. Angle of 2015, Huo et al.
2019 Martin 2016
Sustainability is easy to overlook, but it is an important value for development in the F&T industry, especially during pandemic outbreaks like COVID-19, Lu 2021, Zhao and Kim 2021. The COVID-19 pandemic has created enormous variabilities that push F&T industries to restructure their supply chain practices and make quick changes to adapt to the new environment. Supply chain risks have been reported as the second most important factor affecting the F&T industry, according to the 2020 fashion benchmarking study in the USA, Lu 2021. COVID-19 put more pressures on F&T systems to be lean and flexible to sourcing strategies when dealing with suppliers. Agility has become the forefront during such an epidemic like COVID-19 to handle supplier risks and minimize future wastes. Future development in F&T manufacturing continues to be agility and supply chain integration, SI. As SI has become the forefront in manufacturing for the last few decades, it would be essential to discuss the benefits of lean and green strategies in the context of disruptions such as COVID-19. The purpose of this chapter is to develop a research framework and suggest future directions for lean F&T sustainable development. While previous chapters focus on the technical aspect of lean tools and techniques, chapters, fundamental concepts of lean and agile manufacturing, lean concept in fashion and textile manufacturing, and standardized work in fashion industry, this chapter focuses on structural design and supply chain network that facilitates both lean and green strategies in the F&T industry. Section 1 provides a literature review for lean and sustainable supply chains in the F&T industry. Section 2 describes sustainable benefits, challenges and expectations from lean implementation. Section 3 also provides a research framework for future development of lean and green integration with the importance of supply chain agility, integration and information technology. 2. Lean supply chain in the fashion and textile industry. Literature review has been conducted on case studies and articles describing lean production and lean thinking implementations in the F&T industry. Generally, lean production aims at reducing waste and variability in the processes, adding more value to customers and providing operational performance improvement. Stevenson 2005. Major literature on lean concepts focuses on product and process design, structural design, manufacturing control and planning. While standardization and module concepts can help garment manufacturers like Zara to excel in the market, the postponement process has shown the importance of lean theory in the F&T industry. Afterbet.
2017 Venkatesh and Swaminathan 2004
The supporting goals for lean are to eliminate disruptions from yarns, fabrics to garment manufacturing.
Manfred Sun 2016 Stevenson 2005 Create flexible system to meet diverse customers requirements and eliminate waste. Torres Luna et al. 2020
These goals drive the system to have balanced and flexible flow. Stevenson 2005. Lean concepts have been used for decades and in the F&T industry. Abernathy et al.
1999 Chakraborty and Biswas 2020 Prasad et al. 2020 For Productivity Improvement Adigori et al. 2017 Palanger and Datrack 2021
Lean principles offer a process improvement mindset and engage everyone in the process. Alves et al.
2019 Amaro et al. 2019
However, due to the complexity of the F&T supply chains, organizations are not yet fully aware of the lean principles as they do not apply the approach to an entire value stream,
i.e.
to products or families of products but only to parts of value streams, i.e. to garment manufacturing sectors rather than fabrics processes. The main issue that has been reported in the literature was the lack of integration among different supply chain members. The supply chain in the F&T industry is complex with several factors, namely a short life cycle, high volatility, low predictability, and high impulse purchase. Bruce et al.
2004
Consequently, managing a good supplier-buyer relationship in the F&T supply chain is essential for operational improvements such as reducing lead times and achieving a quick response. These characteristics of the industry highlight the need to use an approach such as agility. Agility is the ability to sense changes and to rapidly and flexibly respond to fluctuations. Christopher 2000, Lee et al.
2008
As rapid and flexible responses may as well be considered elements of supply chain flexibility, which is an important dimension of supply chain agility. Competition intensity and diverse customer needs will continue to push these F&T supply chains to be more agile. In addition, the recent COVID-19 outbreaks further push F&T supply chains to be more agile as well. H&M and Zara have built agility into every link of their supply chains to ensure responsiveness to fluctuating supply and demand through agile design processes. Postponed manufacturing
and State of the Art Sorting and Material Handling Technology, Lee 2004
Besides, pressures from diverse customer needs will foster fast fashion companies like Zara to restructure their supply chain to handle higher product complexity,
e
a wider variety for customer selection. Through supply chain agility, manufacturers can deploy delayed configuration, standardization and modular design that enable firms to cost-efficiently deliver products characterized by numerous styles and sizes, and adjust production processes in response to change in supply and demand. Lee et al.
2008
Standardized parts have a high commonality that can share product platforms and resources that enable firms to meet diversified customer requirements while being competitive in terms of cost and qual.
E.T. Robertson and Ulrich 1998
Zara produces over 450 million items and launches around 12,000 new designs annually. Indeed, the company gained a high level of supply chain agility, exercised efficiently product standardization and postponement strategies to ensure that they deliver new products every fortnight with the constant refreshment of store-level collections goes off smoothly and efficiently. Roll 2020. 3 Lean and sustainable supply chains, benefits and challenges. Several case studies show how lean principles can facilitate efficient F&T production and help the supply chain become more competitive. The following section discusses how lean strategy can align with green practices and directly impact responsible consumption, promoting sustainable industrialization. Shen et al.
2017
Different practices have been used in the F&T industry to pursue environmental sustainability objectives. Previous literature has revealed that lean operations have attempted to veer in several directions, using generic models. Fig. 1 with 3 pillars: social, economic, and environmental aspects. Each has its challenges and benefits to the industry as well as the consumers alike, and each has an impact on the other two.
Fig.
1 Sustainable supply chain model in F&T industry. Sustainability is something that should be easy to understand and something everyone should embrace wholeheartedly. But this has not always been the case. Nayak et al.
2020
Sustainability in the F&T industry, and particularly the environmental concerns, has historically been ignored or at least was avoided due to a lack of understanding or a feeling that individual design could not make a difference anyway. Beard 2008. Where should we start to make a difference? How could we possibly get the attention of industry players if the current leaders in the F&T industry choose not to participate in environmentally sustainable practices? Then perhaps it might be better to turn our efforts towards the future and the industry play. Of the future. Shen et al.
2020
As with other industries, these efforts have started to become more prevalent in higher education by delivering the appropriately designed curricula to bring the underlying issues to the surface. The F&T industry influencers of tomorrow could be the key to building a sustainability mindset. Vietnam is entrenched in the global fashion apparel industry to the point where it is one of the most important economic export elements in the country. Nayak et al.
2019
This sector has the second highest number of exports just behind the electronics industry and employs 1 out of every 5 workers in the total labor force, making it one of the key industries driving the nation's growth. Even during the COVID-19 pandemic, Over the period from 2019-2021, the F&T industry continued to progress steadily as forecasted in 2017 to extend this trend well into 2025, as displayed in Table 1.
The
Export market for Vietnamese products such as textiles and apparel, shoes, furniture, various electronic devices and spare parts shipped to the USA reaching an import-export turnover of $543.9 billion United States dollars, which was up by 5.1% in 2020 over 2019 and showed the highest trade surplus since 2016. In the first 3 months of 2021,
the U.S. market
became the largest recipient of Vietnamese items trading $22.2 billion USD, indicating that the U.S. was moving away from their traditional sourcing nations to other emerging countries such as Vietnam. Table 1 U.S. Textile and Apparel Units
2005 2007 2009 2011 2013 2015 2017
When sustainability is mentioned anywhere in the media, it is the environment that takes center stage, as the world appears to be in crisis mode when addressing issues like pollution causing global warming and the destruction of the shrinking natural habitats all over the planet, from our oceans to forests and other grasslands.
G. Akbari and Hopkins 2019
When addressing the issue of sustainability in the F&T industry, due to the labor-intensive nature of the industry, there is a focus on reducing human rights violations and the ever-present corrupt ion found in such places. Green supply chain management (GSCM) is certainly relevant to the F&T industry. However, achieving good environmental performance is rather difficult. Due to geographically complexity and regional differences within F&T supply chains, coordination and collaboration with supply chain members can be challenging,
especially in monitoring sustainable
practices such as environmental practices in the fabrics manufacturing. Lack of integration with textile suppliers such as yarns and fabrics can be detrimental to sustainable efforts. F&T sectors and the related industries
G.
Yarns and fabrics processing have a significant impact on the environment due to resource and labor-intensive practices. NIAC 2019. From the materials being extracted, sourced, and placed into F&T production, most of them are used only once, being disposed of within the first year of use. Angelov 2015, Gardetian Mutu 2020. Therefore, achieving sustainable production patterns, especially engaging the entire value chain, from raw material to consumer, both globally and locally, become essential for the F&T industry. Gardet.
The and Mutu 2020
Many examples include loose relationships between garment manufacturers and textile producers on supplier environmental performance.
Kanye2 et al.
2012 found that Indian suppliers were unwilling to engage in environmental performance assessment. Similarly, Vermeulen and Ross 2006 identify challenges among the Dutch fashion companies in greening their global fashion supply chain. The results showed an inconsistency between global environmental challenges and company environmental disclosure. However, a disconnection between the specific environmental indicators reported by Textile companies and the garment producers remain the hotspots for the GSCM discussions.
3.1 Sustainable Benefit.
Several benefits may be achieved by the F&T industry, such as performing code of conduct and social audits, collaborating with multi-tier suppliers, as well as offering incentives to the suppliers for being more socially responsible. This aspect is usually neglected by many companies in place of a focus on environmental sustainability. Akbari and McClellan 2020. The common environmental green factors include life cycle assessments, LCAs, CO2, carbon dioxide emissions, and the use of recycled water as a sustainable process that are prominently displayed on company websites and product labels. Since the recent sentiment of consumers is focused on sustainability and the circular economy, it would greatly benefit fashion designers to implement practices that reflect these two factors. Consumers have recently been leaning towards products and production processes that follow stricter, green models. Due to the media attention over the last several years on global population explosions, global warming, climate change, water scarcity, and dwindling farmlands, consumers have taken a position to make A difference by protesting through choices made at the cash register. Brands that have tried to reduce their wastewater, reduce the use hazardous chemicals, and eliminate human rights violations have shown a marked increase in consumers' decisions to buy their products. Fast fashion has been a thorn in the side of this progress as it has taken the low road and gotten worse regarding their wastewater use of chemicals, and human rights abuses. All these can be attributed in the name of meeting the speedier demand of consumers. Heinz and Bruce 2017. With a global turnover of $1.3 trillion and 300 million workers employed in the fashion industry, it is well worth the attention of industry players to understand the impact of consumer behavior and provide the market with what it demands. The best performing companies focused on sustainability by changing their processes and practices in their company governance and manipulating their business models into ones that take advantage of growth that sustainability can bring to the entire supply chain.
3.2 Sustainable Challenge.
As much as sustainability itself has become a mainstay in organizations around the globe, it is still very much misunderstood, Thomas 2008, and confusing to many who seek to incorporate it into their daily business operations or creative outputs.
Unfortunately,
there is no clear definition for what sustainability means compared to what it is not in terms of designing the fashion and the manufacturing of it, leaving consumers to try to figure all this out for themselves. Beard 2008. Due to various players in the industry, from the designers to the material suppliers, to the manufacturers, to the distributors, to the retailers, and finally to the consumers, each views their responsibilities towards the environment and ethical practices differently, making sustainability much more challenging to accomplish. Haugen-Busch 2016. The biggest hurdle to each of the players understanding sustainability the same way is due to differences in their education, life experiences, involvement in social or cultural movements, as well as simply the way it is interpreted. Thomas 2020. One of the many challenges regarding sustainability is the perception that it carries in the business world. Executives call it the S word, with a negative connotation because it goes against everything that they work so hard regarding, growing the business and its market share. At higher level strategy meetings, things like maximizing the ROI, return on investment, squeezing profits, and budgetary models for the company, along with the many challenges of scarcity of resources, make sustainability more of a burden for some business managers. Thomas 2020. The negative customer perceptions of brand compliance, as well as the incompatibility with the customer's value propositions and the lack of scalability of sustainable business models, hinder the industry.
Why?
From making a full-fledged commitment to changing their ways and pushing their supply chains to make similar changes to their practices. Powell and Gander 2018. Perhaps one solution might be to help the fashion industry move from the current practices of simply reporting their sustainability efforts, their financial statements, and corporate statements to taking action, creating sustainability value for those beyond their own company to include their entire supply chain, and making committed changes to their policies, processes, and practices by developing an industry scorecard that would add an element of transparency, thus applying the needed pressure to act on their claims of being a sustainable organization. Garcia Torres et al.
2017.
Besides, several green supply chain practices could not approach the entire value stream,
i.e.,
to products or families of products, but only to parts of value stream,
i.e., to fabric sector.
That disconnection among garment supply chain partners or lack of integration. Rout et al. 2019. Influence how lean manufacturing directly impacts responsible consumption and production.
Lean supplier and greening supplier. Larry et al.
2017. Yu and Huo 2019 have been making major efforts in lean manufacturing that can potentially reduce waste generation through prevention, making industries sustainable with increased resource use, efficiency, and greater adoption of clean and environmentally sound technologies and industrial processes. Nath et al.
2019. Sancha et al. 2016.
Lean green indices are developed to measure the lean green practices in companies. This is important to evaluate and compare green practices. However, literature indicated a mix of measures and inconsistencies among the usages in different industries. Alves et al.
2019.
Since the process-oriented industry like textile and garment has highly inflexible automatic machinery with high volume, low product variety. Mohan Prasad et al.
2020
This complexity of the textile industry renders the introduction of lean manufacturing strategies in a textile market with some measures that represent indicators related to sustainability key envier.
on mental performance indicator KEPI that many times are unknown.
Sustainable Apparel Index was developed by the Sustainable Apparel Coalition (SAC) to measure and promote sustainability built upon a common approach for evaluating sustainability performance (RODIC).
Ishnan 2015
The HIG Index, announced by the SAC, enables apparel companies to measure the environmental and social impact of apparel production throughout the product lifecycle. From design to end of use or recycling of the product, Althaute HIG Index can be applicable for many organizations in an apparel supply chain. Implementation of a common tool and technique can be challenged as different size, companies' visions, and cultures. Figure 2 provides an overview of the sustainable associates of fashion brands in their supply chains.
Fig
2 Which, if any, of the following fashion brands or shops do you associate with having a sustainable supply chain?
Source adapted from Statista 2021
4 Future directions: lean and sustainable supply chains. The textile sector continues to experience significant environmental issues related to the production process, including overuse of chemical products and natural resources, resulting in a high environmental impact. Bubich et al.
2021 Gadetian Mewtwo 2020 Radhakrishnan 2020
Moreover, due to geographical complexity and regional differences within F&T supply chains, coordination and collaboration with supply chain members can be challenged.
especially in monitoring
Able practices such as environmental practices in the fabrics manufacturing. This section proposes a framework where lean strategy can align to green supply chain practices to ensure a balanced flow of textiles and garments. The discussions from previous sections provide a foundation for integrating agility, supply chain integration and technology to lean and green approaches. These approaches can facilitate F&T companies to direct their efforts during situations such as COVID-19 pandemic. Figure 3 proposes a framework to elaborate linkages between lean and green strategies in F&T operations with agility, integration, and supply chain technology. Shen and Lee 2019 Fig. 3 Future lean supply chains and agility, COVID-19 pressures. Source adapted from Butt 2021 and Hook 2020. COVID-19 puts more pressure on F&T systems to be flexible in sourcing strategies when dealing with suppliers. Supplier risks have been reported as the major source of supply chain disruptions, especially in the F&T industry. Butt 2021, Hook 2020. Some strategies such as supply reduction base or centralization might not be effective. During the COVID-19 pandemic, we can see the trend of increasing buffering and switching suppliers. Especia et al., 2021. Hook 2020. When looking at the scale of supply value chain disruptions, COVID-19 has hit hard in many F&T manufacturing nations including Bangladesh, China, Mexico, Turkey, and Vietnam. Figure 4 indicates apparel production levels in these major F&T manufacturing countries reflecting the major supply chain disruptions. Literature mentioned a triple hit to global manufacturing due to the pandemic, referring to direct supply disruptions, demand disruptions and supply chain contagion. Supply chain contagion can be seen in F&T supply chains when Chinese textile materials and fabrics become more expensive or impossible for importing due to cross-border trade suspension during COVID-19. These amplifications created direct supply shocks in F&T sectors in less affected nations e.g. Vietnam that find it harder and or more expensive to acquire the necessary imported fabrics and garment inputs from China. Dao et al.
2020
Therefore, achieving more sustainable production patterns, especially engaging supplier environmental monitoring and involving the entire value chain from a holistic perspective, from raw material to consumer, both globally and locally become essential for the F&T industry. Gardetti and Mutu 2020.
Fig
4 Apparel production in major fashion and textile country. Source Unido.
2020
Agility has become the forefront during such an epidemic like COVID-19 to handle supplier risks and minimize future wastes. The benchmark study among USA textile manufacturers indicated that U.S. fashion companies are more actively exploring made in the USA and nearshoring opportunities to improve agility and flexibility. and reduce sourcing risks. Lu 2021. Expected in the aftermath of the COVID-19 outbreaks, F&T supply chains are increasingly required to balance the management of key lean capabilities with resilience.
Responsiveness and Growth et al. 2019
The lean, agile and agile approaches supply all effective sequences and manage the manufacturing process to reduce lead times. Bruce et al.
2004 Purvis et al. 2014
This is particularly relevant to the textiles and clothing industry, characterized by highly volatile markets, short product life cycles and high product variety. Besides, due to the small size of these garment and textile firms, there are increased competitive forces compounded with small businesses where the problem becomes more challenging with less resources.
Available Bruce et al. 2004
Agility plays an important role as the F&T sector has extremely low profit margins, so that producing and even holding small quantities of stock is not commonly a viable option. The incidents from COVID-19 supply shortage in F&T industry, many firms could not store large quantities of materials, and as fashion products have a very short life cycle and are seasonal. Zara observed global store closures amid the COVID-19 crisis in 2020, with sales falling 44% year-on-year in Q1 2020 and company reporting a net loss of $482 million USD. Roll 2020 COVID-19 has resulted in a widespread sales decline and order cancellation among U.S.
fashion company.
Almost all respondents, 96%, from the recent benchmark expect their company's sales revenue to decrease in 2020, Lu 2021. Therefore, the literature suggests that the textiles and clothing industry should try to combine lean and agility, which is often referred to as legality, which handles the two drivers of low margins and volatility of demand. This would ensure fast product replenishment, the building and maintaining of supply chain partnerships and flexibility in response to the volatility of demand from retailers. Lu 2021, Purvis et al.
2014 เจ้า and King 2021
These authors suggest increasing sourcing diversification and reshoring manufacturing and increasing flexible capacity plans. It was difficult to redirect to other sourcing destinations to China was hit hard by COVID-19. The increasing production and sourcing cost and associated logistics scandals such as Suez's Canal put more pressures on shipping and logistics cost in 2020 and potentially in the next few quarters. Lu 2021, Zhao and Kim 2021. These authors observed that during COVID-19 and the USA-China trade war, more sourcing diversification and reshoring manufacturing become necessary, without any alternate choice. Around 29% of respondents indicated that they source more from Vietnam than from China in 2020, up further from 25% in 2019, Zhao and Kim 2021. The trend continues to diversify their sourcing destinations, with 42.1% currently sourcing from more than 10 different countries or regions. Zhao and Kim 2021. Nearshoring and reshoring manufacturing capabilities are emerging topics in the fashion industry. Recent research indicates the need for flexible supply source planning can help F&T companies avoid global trade disruption.
Castaneda Navarrete et al. 2021 Exter et al. 2020
Deploying nearshoring opportunities supports flexibility and better autonomy for production. This is extremely important for the textile and garment industry where the life cycle becomes shorter due to customer diverse experience.
In the recent Fashion Benchmarking Report 2020 LU 2021 indicate that U.S.
fashion companies now are more actively exploring, made in the USA, sourcing opportunities to improve agility and flexibility and reduce sourcing risks. Approximately 25% of the respondents expect to increase sourcing locally in the United States in the next 2 years, which would be the highest level since 2016. 5. Future lean and supply chain visibility. Future development in F&T manufacturing continues to be agility and supply chain visibility (SCV). Zara has claimed a super efficient and super flexible supply chain. Zara demonstrates the ability to overcome the vagaries of the fast fashion industry by its agility and is considered legendary. Zhelyotskov 2011, launching thousands of fashion models in a fortnight. Besides, the pressure from e-commerce and omni-channel marketing increases the need for speed, quick and visible inventory turnover. SCV has become the forefront in manufacturing for the last decade, it would be essential to discuss the benefits of lean and green strategies in the context of disruption of COVID-19. To be truly agile, research indicates the need to enhance market-sensitive capabilities together with abilities on sharing information across all supply chain partners, Bruce et al.
2004 Brexit 2016
Visibility capabilities provide companies tracking and tracing of goods flows and reporting tools. INA supply chain. Visibility capabilities often referred to as boundary-spanning or inter-organizational technologies that link supply chain members as well as other procedures,
Processes and routine
which enable distinct firms to work together towards a common goal. Research indicated that visibility capabilities can bring not just information but know-how and other intellectual capital, which enables firms to make informed decisions. Christopher 2000. These techniques can be integrated with ERP, enterprise resource planning systems, and with other supply chain management software to enhance agility in a supply chain. Brusset 2016. Visibility brings many influences on lean and supply chain integration. During the COVID-19 pandemic, manufacturers have demanded greater visibility into the supply chains of their suppliers so that the brand or retailers can be more dynamic in their planning. In the fashion and textile industry, this capability remains the essential partnerships between brands, retailers, and suppliers around the world. On the other hand, it pushes up the level of confidence in the long-term outlook for the fashion industry. Chatham et al.
2020 B
So, it is more important than ever for fashion companies to work with their suppliers to develop joint collaborative activities. Enhance information and linkage to meet the key sourcing goals of speed to market, flexibility and agility, sourcing cost control and low compliance risks. COVID-19 has caused severe supply chain disruptions to global fashion companies, reflecting the increasing number of order cancellations and supply shortages. COVID-19 has resulted in a widespread sales decline and order cancellation among
S Fashion Company
Almost all respondents, 96%, expect their company's sales revenue to decrease in 2020, Lu 2021. The fragility of the clothing supply chain operating in South Asian countries indicating by a lack of detailed information on supply disruption and sourcing contracts, Majumdar and Sinha 2020. Nearly half of self-identified retailers said the sourcing orders they canceled or postponed without much notice. Another 40% expected order cancellation and postponement could extend further to the fourth quarter of 2020 or even beyond. The order cancellation or postponement has affected vendors in China, Bangladesh, and India the most. These discussions raise the importance of the information infrastructure in alignment to the company objectives.
6 Future Lean Supply Chain are Digital
To connect different lean tools, supply chain technologies are essential. The exchange of information and data between F&T buyers and suppliers is crucial for agile supply chains. Christopher 2000. Firms need to have the capability to react to possible volatile fluctuations in demand. Improving supply chain visibility among members can help companies reduce the amount of inventory held in anticipation of predicted and often distorted demand. Akbari and Ha 2020.
For many industry
Using different information technologies become essential to sustain the extended enterprise where collaborative alliances support the exchange of information to enable such activities as joint product development and common systems. Bruce et al.
2004
The real strength, however, does not lie in the individual information technology tools but in the integration of these tools with the redesigned production processes. Tools embedded with the synchronized information and production flow for their smooth functioning would bring about the reduction of non-value-added activities and increase customer satisfaction. Mamo.
Ot 2020
Chapter, Digital Technologies for Lean Manufacturing, has discussed some of the important technologies and their fundamental principles in the implementation of lean manufacturing in F&T industries.
This chapter briefly highlight how different technologies such as blockchain, big data, RFID, radio frequency identification, ERP system,
and the Internet of Things (IoT) will influence the future of supply chain in the F&T sector. The next section discusses some of the recent technologies' potential impact on lean and green partnerships. Kumar et al.
2012
A study by Wong and Ha Brookshire 2018 demonstrated the growing demand for digital competency amongst common fashion supply chain functions: forecasting, consumer research, design,
Product Development
merchandising, sourcing, production and retailing, distribution. Digital competency, which can be defined as possessing abilities and skills, or competency, to deal with digital resources and environments. Prifty et al. 2017 has been noted to be of particular importance in the initial stages of the fashion business cycle, forecasting, consumer research and design. Further competencies in the area of social media and social networks were deemed important, being able to identify the DNA of a specific brand on online searches and analytical capability leveraging a variety of channels such as magazines, the internet and retail shopping to be able to identify and present market trends. Wong and Ha Brookshire 2018 identified downstream functions required less but more focused digital competency. For example, sourcing required strong competency in product lifecycle management APLA. Cations and distribution required skills that focused on ERP system knowledge and skills. This trend of increasing digital competency is driven by the continuing evolution of supply chains from Industry 3.0 to Industry 4.0, and studies have indicated that the future of the F&T industry involves adopting the major characteristics of Industry 4.0 as the focus shifts towards customer-oriented products, rapid response, and customer service, all of which are key goals of Industry 4.0.
Chen and Sing 2016
Organizations have and are continuing to realize the need to remain competitive through the use of digital technology. Chen and Xing 2016. A supply chain that is powered by emerging technologies such as blockchain and the IoT will nurture collaboration, drive visibility and allow for Chen and Xing better decision-making and risk identification and management. Integration through technology will allow for organizations to engage suppliers with common visions, develop symbiotic relationships across functions and allow for better measurement of performance and accountability of responsibilities. When looking towards the future, emerging markets also need to be considered along with their impacts on the global economy. Economic growth and the increasing appetite of China and other developing countries for resources is advancing global prices, which in turn makes it more complex to plan and configure supply chain as.
Sekosre and Pandit 2021
This in combination with the growing corporate awareness of sustainability and greater government regulation adds to the complexity and uncertainty faced by those in supply chain management.
Le et al. 2019 Ken et al. 2021
The digitization of supply chains has been a strategic evolution that has been ongoing for years as technologies mature and mainstream acceptance increases. Akbari and Du 2021. However, the COVID-19 pandemic acted as a catalyst for digital transformation and a sharp reminder of the costly impacts of disruption on supply chains not geared towards flexibility.
Reshaping how PO
Plea in the industry are thinking about the future of the supply chain management. Shatman et al.
2020 B
Digital transformation of supply chains may also allow for more decentralized supply chain models.
Chamit et al.
2015 suggested that using a decentralized design reduces cost variance through the risk diversification effect, thus splintering traditional monolithic supply chains into smaller ones, providing more resilience and flexibility. While decentralized, splintered supply chains utilize the same assets and resources. The key to its success is the utilization of information through technology, which assist in the management of
Complexity.
This approach may suit organizations that are risk-averse looking to minimize disruption. 6.1 Blockchain and the Internet of Things. Two technologies that have promising potential to revolutionize the F&T supply chain are blockchain and IoT. Blockchain is considered to be a very disruptive technology, having the potential to impact and affect material change in most if not all industries. While research and application of blockchain started with a focus on financial transactions and distributed ledgers, it has major future implications on the financial sector, providing alternative structures and models which promote financial activities without the need of trusted and centralized intermediaries such as banks. Tapskit and Tapskit 2017. Wong and Ha Brookshire 2018 put forward that blockchain has the potential to disrupt many other domains, with the nature of blockchain allowing for the secure exchange of data using a decentralized
model.
It will, in turn, change the way an organization is governed, how relationships across the supply chain are structured and how transactions are handled. Lean supply chain management in the F&T industry also stands to gain the same benefits. Traceability has been a persisting problem in the F&T supply chain, while transparency is arguably a more impactful issue that is also not well addressed. Elmasary 2018. These issues have an exacerbated impact across participants of the supply chain and pressures entities to create local nodes to use localized information. When blockchain is integrated with other maturing technologies like IoT, it is possible to document and share actionable records related to a product's end-to-end journey through the supply chain. Wong and Ha Brookshire 2018 asserted that creating this level of visibility where each step and action can be recorded and shared securely affords a level of traceability, authenticity and legitimate that current systems are unable to attain. In addition, other benefits can be gained, such as compliance, error reduction, and payment processing. Tapskit and Tapskit 2017, while IoT allows for the generation of big data. Wong et al.
2019
While the possible benefits of blockchain and IoT are widely related to traceability and transparency being an obvious benefit, the current application of supply chains and in particular within the F&T industry is still maturing. To realize these benefits, Sunny et al.
2020 6.2 Cloud Computing
Cloud computing technologies offer several benefits which range from scalability to reduction of cost. However, the biggest benefit cloud computing has on LSCM, logistics and supply chain management, is the ability to integrate a variety of different platforms, enabling synchronization and collaboration. Across the supply chain, Dave et al.
2016
It is possible due to the integration of cloud computing and mobile technology that has evolved to modern standards, allowing for a real-time flow of information. Available for consumption anywhere. Sanders
et al. 2016
Due to the aforementioned benefits, supply chains can react and make decisions in real time, in turn reducing, mitigating and potentially preventing the bullwhip effect.
6.3 Artificial Intelligence AI
Decision-making has always been difficult in supply chain management due to the complex nature and uncertainty of the environment. Inaccurate demand forecast and decision-making can often lead to undesirable situations such as overproduction, logistical wastage and delays leading to financial costs and opportunity costs. The application of AI in F&T industry is broad and yield many benefits.
For example, Torres Luna et al.
2020 demonstrated benefits such as the elimination of waste in production, reduction of inventory surplus, reduction of lead and waiting times, improved efficiency in the movement of materials and the overall increase in productivity in the entire lean supply chain. AI has also been applied to analyze and traffic to optimize delivery routes, improving just-in-time JIT models, reducing delivery times, and increasing customer satisfaction according to Kong et al.
2019
To further improve profitability, AI was applied to schedule product deliveries, optimize a fleet with multiple delivery vehicles, and delivery time requirements, resulting in more efficient fuel
Consumption and Maximizing Profitability Kang et al. 2019
There has been a wide range of applications of AI in F&T industry that can help to achieve the objective of lean manufacturing. Nayak and Padye 2018a, b.
6.4 Big Data
The application of the above technologies would lead supply chains to generate large amounts of data. These datasets would be critical in evolving LSCM, being able to mine useful information and knowledge from various data points across the supply chain. Bevilacqua et al. 2019 allowing for data visualization, analysis of key metrics and the enablement of semi-automized or automized decision-making throughout the supply chain. Roy and Roy 2019 As LSCM adopts more digital technology, the generation of data will continue to proliferate. LSCM leaders will increasingly rely on data from their digital ecosystem to allow them to measure efficiency from various functions in the supply chain ranging from their carbon footprint, performance of supply communities, customer experience and satisfaction. Nguyen et al.
2015 Plumbeck 2012
6.5 Virtual Reality, Augmented Reality, VR/AR. VR and AR have been applied more widely in various industries such as tourism, entertainment, and education to name a few. However, in the F&T industry there are limited applications. Walter et al.
2009
AR has been applied more widely due to the technology being available on mobile devices and has resulted in AR-based fashion applications, allowing customers to view products within their environments.
Walter et al. 2009 However, De Silva et al.
2019 suggested that new product development in the apparel industry will be collaborative and demand virtual simulation technologies. The two technologies will provide benefits to different stages, with VR technologies providing more benefit to collaboration on new product design in the development stage such as prototyping, while AR tools being complementary for consumer integration stages such as concept tests and fit assessments. It should be noted that while possibilities of VR/AR technology are evident, there is very little literature indicating the immaturity of the technology.
7. Conclusion
This chapter provides a comprehensive review of literature and cases describing lean supply chains and sustainable development in the fashion and textile industry. While previous chapters deal with different tools and techniques, especially chapter, Digital Technologies for Lean Manufacturing, discussing various technologies that can be integrated with the lean manufacturing, this chapter discusses several approaches to enhance lean and green supply chains to ensure smooth production and distribution of fashion and textiles products. The chapter places fashion and textile positioning in the volatile and disruptive environment like COVID-19. Lean manufacturing has been used for decades and continues to be important for fashion and textile in reducing wastes, minimizing disruptions, and creating a balanced flow of products. Agility and visibility have been at the forefront in supporting lean manufacturing and supply chain development. This chapter confirms the importance of lean thinking, which could be applied in alignment with solutions to the sustainability paradox in the fashion and textile industry. This chapter also discusses the future development of sustainable fashion and textile industry in alignment between lean, agility, and visibility. Information technology plays a crucial role in linking lean, agility, and visibility through promoting a culture of continuous improvement, engaging everyone in the process. This chapter has briefly explained how the digital technologies such as blockchain, big data, RFID, ERP systems, and the Internet of Things (IoT) will influence the future of supply chain in the fashion and textile industries. The implementation of some of the recent technologies has the potential on lean and green partnerships to make the fashion and textile sector more productive as well as to meet the sustainable standard. In product manufacturing,
Reference
Abernathy F.H., Dunlop J.T.,